Hello and welcome to Algebra 1, Lesson 40. In this video, we're going to learn about factoring trinomials with a leading coefficient that is not equal to 1. So in our last lesson, we learned how to factor a trinomial that looks like this. ax squared plus bx plus c, where a, the coefficient for the x squared, is a 1. Now this is the easiest scenario. So if I had something like, let's say x squared plus 5x plus 6. I would set this up as the product of two binomials. I know that since the coefficient of this is 1, it's very easy to get the first two. So x goes here and x goes here, right? Because x times x gives me that first term of x squared. Then for these two missing parts here, I just need to figure out two integers whose sum is 5, right? That middle term there, the coefficient for the middle term, and whose product is that constant term, 6. That's why we say a sum of b and a product of c, right? So this is b and this is c. All right, so once we figure that out, we just place those two integers in those missing spots. So two integers that would multiply together to be 6 but sum to 5 would be positive 2 and positive 3. So x plus 2 times x plus 3, those two quantities multiplied together would give you x squared plus 5x plus 6. But this is the easy scenario to deal with. Hopefully at this point you've mastered that. We're now going to look at the harder part, which is to say now we will focus on factoring trinomials of the form ax squared plus bx plus c, where a is not equal to 1. Right? So this will no longer be 1. So I can't just jump ahead and say, okay, this is x and this is x, because you won't have that in each position anymore. So that's going to be another unknown that you have to deal with. So how do we do this? So there's two main methods that pretty much everybody's textbook will rely on to show you how to factor a trinomial when the leading coefficient is not 1. Now, the first method relies on factoring by grouping. This is the method I primarily use. I still use it today. I think this method is fast, easy, and efficient. The other method is reverse FOIL. I do not like this method. Personally, I find it to be just a complete waste of my time. It's trial and error, and even though I'm pretty good at it, it still ends up taking me longer in most cases. I'm going to teach you both because your teacher might require that you demonstrate the ability to do both. So I want to cover everything completely. But you get the same answer either way, and this method is so much easier for me, and I always use it. And I know there's some tricks out there on the internet. Whatever you find that works for you, do it. Again, I like this method. It's never let me down, so I'm going to start out with this. So the factoring by grouping method. The first thing you're going to do, and you do this always, you factor any common factor. This will save any additional work in the end. So if I have a trinomial and there's a factor that's common to everything that I can pull out, I'm going to go ahead and do that and then work with what's inside the parentheses. All right, so the next thing I want to do, consider the trinomial ax squared plus bx plus c. You want to look for two integers whose product is ac. Before, you were just looking for the product of c. But really, if a is 1, 1 times c is just c. So it's the same thing. You're just adding this right here because now it's not equal to 1. So the product is ac and the sum is b. So when you find those two integers, you're going to use the integers to rewrite the middle term so that we have a polynomial with 4 terms. And I know that might be a little confusing, but once you see me do an example, that's going to really resonate with you and show you how easy this is. So then at this point, we can use factoring by grouping. All right, so let's start out with the first example. We have 5k squared minus 18k plus 9. So again, this is my A, this is my B, and this is my C, just for reference sake. When I start, I always look to see, is there anything common to everything, something I could pull out? Well, there's not. I have a 5, that's prime. 18 is not divisible by 5, so I can just stop. So nothing I could pull out. So again, I want two integers whose product is A times C and whose sum is b. So b is negative 18, and AC, 5 times 9, is positive 45. So we know we have to have two negative values, right? Because if I have a positive sign here and a negative sign here for the sum, I've got to have two negatives. Two negatives will multiply together to give me a positive. Two negatives will sum together to give me a negative. So what are some factors of 45? And let's just think about positive factors, and we'll make them negative. So we have 1 times 45. Obviously, that's not going to work. Not divisible by 2. It's not an even number. 4 plus 5 is 9, so it is divisible by 3. 45 divided by 3 is 15. So let's stop there. We can see that 3 plus 15 is 18. We just need to make the signs work, and to do that, we just make a -3 and a -15. Now, in the last kind of section, we were done at this point. We got our two integers, we threw them in, and we were done. It's a little bit more work here. You've got to rewrite your middle term into a polynomial that's 4 terms. So I'm going to take this and write it as 5k squared minus 15k minus 3k plus 9. And I did two things there that I want to explain. The first thing is that I rewrote the middle term as -15k minus 3k. I have not changed the value of this polynomial. -15k minus 3k, if I combine like terms, I'm going to get -18k. That's perfectly legal. We've seen that with fractions and all kinds of other stuff where we change what it looks like, but the value is the same. Now, the second thing is I put 15 next to 5 because I know they have a common factor of 5. I put 3 next to 9 because I know they have a common factor of 3. So I did that because, remember, if you're factoring by grouping, you want to put your groups together in a way to where you know you have some common factor you can pull out. So that's why I did that. All right, so now we're going to factor by grouping. So in the first group, I can pull out a 5k. So I would have 5k outside. Inside, I would have a k minus a 3. And then in the second group, I would pull out a -3. So I'm going to put plus -3 times what's left in there. You would have a positive k minus 3. So you can see you have a common binomial factor of k minus 3. Common binomial factor. So let's factor that guy out. So this is equal to 5k minus 3 times k minus 3. If I took out the k minus 3 and put that here, what would be left is a 5k minus 3. So that's why I have 5k minus 3 times k minus 3. And I'm done. I've completely factored this guy. As long as I didn't have a common factor when I started, I won't have one in here that requires additional work. I should be done. The only thing I have to do now is check. 5k times k is 5k squared. 5k times -3 is minus 15k. -3 times k is minus 3k. And then -3 times -3 is plus 9. So you can see I got exactly back what I had here. If I combine like terms, I'd get -18k in the middle, and then I would have exactly what I started with there, 5k squared minus 18k plus 9. Okay, let's take a look at another one. So we have 7a squared plus 17a plus 6. So again, I'm looking for two integers whose product is AC. So again, this is A, this is B, and this is C. And I know this is ultra confusing because I now have a variable that's A. Okay, I have a variable that's A, but you can kind of ignore that. Typically, we have what? We have AX squared plus BX plus C. So the coefficient for the square term, in this case it happens to be an A, it's A squared, is denoted with A when we talk about a generic formula. So it's just whatever the coefficient on the square term is times whatever that constant is. So 7 times 6 is 42. And then sum is B, which is 17. Right? So whatever that number is, okay, including the sign for your middle term. Right? In this case, that's 17. All right, so moving on. What two numbers would multiply together to give me 42 and sum to 17? Well, we think about the factors of 42. We've got 1 and 42. We've got 2 and 24. Then 4 plus 2 is 6. 6 is divisible by 3, so 42 is 3 times 14. And that looks like that would work, right? 3 plus 14 is 17. 3 times 14 is 42. So again, at this point, we're not done, right? Before we were done, we found our two integers. We throw them in. We're not done. We're going to use that to rewrite that middle term. So we're going to break it up into 7a squared plus 14a plus 3a plus 6. And again, notice that I put 7 next to 14, 3 next to 6, right? Because I know I can pull a 7 out of here and a 3 out of here. So that's why I did that. All right, so the GCF for these two would be 7a. The GCF for these two would be 3. So then equals, if I pull a 7a out of there, I'll have 7a times a plus 2. If I pull a 3 out of here, I'll have 3 times a plus 2. So if I factor out that common binomial factor of a plus 2, right, if I pull that guy out, I'll have a plus 2. And what's left? I'll have a 7a plus a 3. So a plus 2 times 7a plus 3. And again, check this with FOIL. A times 7a is 7a squared. A times 3 is 3a. 2 times 7a is plus 14a. So 14a plus 3a would be 17a. And then 2 times 3 is 6. So you get 7a squared plus 17a plus 6. All right, let's try negative 12v squared minus 24v minus 9. So everything is negative here. So I know I can pull that out to start and make my life a lot easier. I hate working with negatives. Everybody does. I also notice that everything is divisible by 3. So let's pull out a negative 3, and we'd have 4v squared plus 8v plus 3. So now I just need to worry about what the inside of the parentheses here would factor to. So again, I'm looking at the a, or the coefficient for the squared term, and I'm looking for the c, which is the constant. So multiply those two together. 4 times 3 is 12. So product of 12. And then I'm looking for a sum of 8. So what are some factors of 12? We have 1 and 12. It's not going to work. We have 2 and 6. That would work. So let's rewrite that middle term. So we're going to have equals negative 3 times 4v squared. And I'm going to put plus 2v here. And then plus 6v here. Then plus 3. And then equals, we'll put negative 3 out in front. We will break this up. The greatest common factor here is 2v. So we'll put times, we'll have 2v times. If I take that out, I'll have a 2v plus a 1. So then plus, the GCF here is 3. So if I pull that out, I'll have a 2v plus a 1. And then if I factor out the common binomial factor here, that's 2v plus 1. What am I going to have? I'll have a negative 3 out in front, and then I'll have 2v plus 1 multiplied by 2v plus 3. So there's my answer. Negative 3 times 2v plus 1 times 2v plus 3. And again, you can check it. In the interest of time, we still have a lot to cover. I'm not going to check it. But just use FOIL for this, and then multiply by negative 3, and you should get negative 12v squared minus 24v minus 9 back as your answer. All right, let's take a look at one more, and then we'll look at the reverse FOIL. So we have 20m squared plus 6m minus 36. So everything is divisible by 2. So let's pull that out to start. So I'd have a 2 out in front, and then 10m squared plus 3m minus 18. And then I'm looking at what's inside the parentheses here. So remember, I want a product of 10 times negative 18, that's negative 180, and a sum of 3. So we think about that. We know that we're going to have a positive and a negative. So what are some factors of 180? Well, you've got 1 times 180. That's not going to work. You've got 2 times 90. That's not going to work. You've got 3 times 60. That's not going to work. You've got 4 times 45. Not going to work. You've got 5 times 36. Not going to work. You've got 6 times 30. Not going to work. Then you've got 10 times 18. That's not going to work. What else do we have? We have 12 times 15. 12 times 15 would work. For some way to work those signs out to where I can get 3. In my head, I just look at 12 and 15. I know 15 minus 12 is 3. So positive 15 and negative 12. So let's rewrite this. So we have 2 times, inside of parentheses, 10m squared. I'm going to rewrite that middle term, that 3m, as plus 15m and then minus 12m. Right? If I combine those together, I get plus 3m and then minus 18. Okay, So if I factor this by grouping, I'll have 2 times inside the parentheses. Here I would pull out from this first 2 a 5m. So 5m times 2m plus 3. Then from this one, I'm going to pull out a -6. So minus 6 times, you'd have 2m plus 3. So my common binomial factor is 2m plus 3. It's really easy to see. I can pull that guy out. So I'd have 2 times 2m plus 3 times what's left. I'd have a 5m minus a 6. So 2 times the quantity 2m plus 3 times 5m minus 6. So again, if you want to check this, use FOIL here, then multiply the result by 2, and you should get 20m squared plus 6m minus 36 back. All right, so now let's learn an alternative method which involves reversing FOIL using trial and error. And again, I just want to state that I personally don't like this method. I don't use it. I find it to just be very tedious and very time consuming. I like using the factoring by grouping method. But for yourself, if you enjoy using this, if this is more productive for you, by all means, we're just trying to get the correct answer in the end. All right, so I want to start out with just a demonstration of FOIL and then showing you how we would go about reversing this. So we know FOIL is first term, so 2x times x is 2x squared. So this is the f. Then outer terms, 2x times 4 is plus 8x. This is the O. Then inner, 3 times x is plus 3x. This is the I. And then last, 3 times 4 is 12. So plus 12. This is last. So if we combine the outer and the inner, we're going to get a middle term that's 11x. So this is equal to 2x squared plus 11x plus 12. Now, what if I was to give you the 2x squared plus 11x plus 12, just like this, and I take this information away. So let's scroll down past it and cover it up. And I tell you, I want you to factor this into the product of 2 binomials, and I don't want you to use factoring by grouping. I want you to reverse the FOIL process. So the first thing is, let's think about FOIL. So we have the f, that's the first terms. So something times something gives me this guy right here, the 2x squared. So what are the possibilities for that? Well, since 2 is a prime number, really you can only do 2 times 1, and x times x is x squared. So 2x times x is basically what you could do. Now, you could consider negative 2x times negative x, but everything is positive here, so you really don't need to think about that. You don't need to get that involved. You could say or, negative 2x times negative x, but we really don't need that, right? All the signs are positive. So if I just write out 2x times x like that, I know that 2x times x would give me 2x squared, so that's done. Now, the next thing I would look at, I would skip the outer and the inner, and I would look at the last. The last term here and the last term here will produce 12 when they're multiplied together. So I've got to go through all the factors of 12 and see what combination would give me a product of 12 and a sum of 11x. So that's where we talk about trial and error. For your factors of 12, you have 1 times 12, you have 2 times 6, and you're going to have what? 3 times 4. Now, you have the negative versions of these, negative 1 times negative 12, negative 2 times negative 6, negative 3 times negative 4. But again, all the signs are positive, so we don't really need to think about those at this point. So what I would do is, I would go through, again, trial and error. You'd have, let me put this down here, 1 times 12, 2 times 6, and 3 times 4. So let me make all the scenarios up. So you have 2x and x, and then you have 2x and x. So first I'm going to vary 1 and 12. Now I'm going to put plus 1 and plus 12. So what I need to check here is the outer and the inner. Let me kind of move this down a little bit so I can show you that. So in other words, the outside here, 2x times 12 is 24x. The inside here, 1 times x is 1x. If I combine like terms with that, would I get 11x? The answer to that is no. So that's not going to be my solution. So I would start with something else then. Now I could reverse the order here and try 12 and then try 1, but there's one little tip that I want to give you. If your original trinomial did not have a common factor, then you're not going to have a common factor in any of the binomials. So in other words, this has a common factor of 2. I could pull a 2 out and I'd have x plus 6. So this isn't a possibility. So we can eliminate that. And once we've eliminated that, we can cross this one off the list. That's not going to work. So now let's try 2 and 6. Now if I put 2 here and 6 here, again, there's a common factor of 2. So that's not going to work. So if I switch that up and put 6 here and 2 here, common factor of 2, that's not going to work. So that's eliminated. So now I'm just down to 3 and 4. So I can put 3 here and 4 here and try that. So the outer, 2x times 4, would be 8x. The inner, 3 times x would be 3x. If I add those two together, 8x plus 3x is 11x. So here's my factored form. I have 2x plus 3 times x plus 4, those two quantities. And we know that because we did this problem earlier, right? We saw it from kind of this form, 2x plus 3, 2x plus 3, x plus 4, and x plus 4. So you can see that's a lot more tedious, a lot more involved. And I gave you an easy scenario, right? The coefficient on the x squared term is a prime number, and everything is positive, so we have a lot less work with this versus another scenario, which would be more complex. Okay, let's take a look at 5x squared plus 26x plus 24. So again, I'm going to set this up as the product of two binomials there. And for 5, that's a prime number. So I'm thinking about what? 5x times x. Again, everything is positive, so I really don't need to think about negative 5x times negative x. I don't need to involve that. So I'm just going to start out with 5x times x. That's for the first part of FOIL, right? F. So that's what that comes from. Now I'm going to do the L. So for 24, something times something has got to give me 24. So what are the factors of 24? Well, I've got what? I've got 1 times 24. I've got 2 times 12. I've got 3 times 8. I've got 4 times 6. And then that's going to be it. So if I start with 1 times 24, let me kind of look at these scenarios here. So 5x and x. Let me make out a few different scenarios. So I've got positive 1, positive 1, positive 24, and positive 24. And then I'll check 2 and 12 also. So plus 2, plus 12, plus 12, and plus 2. So you can kind of set it up like this and check it very quickly. So all you're looking at is the outer. So forget about the x for a second. 5 times 24 is 120. The inner would be 1. So 120 plus 1 is 121. That's not going to get you to 26. The outer here, 5 times 1 is 5. The inner, 24 times 1 is 24. 5 plus 24 is 29, so that's not going to work. So this one is eliminated. Then for this one, 5 times 12 is 60. The inside, 2 times 1 is 2. So that's 62. That's not going to work. 5 times 2 is 10. 12 times 1 is 12. 10 plus 12 is 22. So that's not going to work. So you can get rid of all of those scenarios. None of those work. And now we can go on to 3 and 8. And let's try 4 and 6 if we need to. Okay, so 5 times 8 is 40. 3 times 1 is 3. 43 is not going to work. 5 times 3 is 15. And then 8 times 1 is 8. 15 plus 8 is 23. That's not going to work. So this is eliminated. So now I'm down to the last possibility. I have 5 times 6. That's 30. And then 4 times 1 is 4. That'd be 34. And then in this possibility, 5 times 4 is 20. And then 6 times 1 is 6. That is 26. So it's the last one. So it's plus 6 and plus 4. Let's erase all this. And again, that's the problem with trial and error. Sometimes you get it right away. Sometimes you have to go through all the possibilities. You get it in the end. So 5x times x would be 5x squared. 5x times 4 would be 20x. 6 times x would be 6x. 20x plus 6x is 26x. And then 6 times 4 is 24. So what if we had 12x squared plus 9x minus 30? The first thing you notice is that this has a common factor of 3. So I could pull that 3 out, and I would have 4x squared plus 3x minus 10. So if I try to factor this as it is without pulling this out, that trick where I talked about you can't have a common factor in the binomial is not going to work. So that's why I do this to start, make my life a lot easier. So again, if I set this up 3 times and have this scenario, so what would go here and here? For 4x squared, I could do a few different things. Let's start out by just looking at 2x and 2x, right? 2x times 2x would give me 4x squared. Then the possibilities for negative 10, I've got 1 times negative 10. I've got negative 1 times positive 10. I've got negative 2 times 5. And I've got positive 2 times negative 5. So those are my possibilities. So let's run through these really quickly. And a lot of these we're going to be able to skip over. And I'll show you why. Okay, so if I want to use 1 and negative 10, any way I do it, I'm going to have a common factor of 2. So I can eliminate that. Again, same thing here. If I want to use negative 2 and 5, I'm going to have a common factor of 2. So that's eliminated and that's eliminated. Either negative 2 or positive 2. Because I've got to put it on one of the sides and I'd have a common factor. So this is eliminated right away. So I've got to go to a different one. I've got to go to 4x times x. Let's try that. So 4x, 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 and then my x is over here. So then again, the possibilities for negative 10, I've got negative 1 times 10. I've got positive 1 times negative 10. I've got 2 times negative 5. And I've got negative 2 times positive 5. But again, because of the common factor thing, there's only so many arrangements I can use. So I can't do a 10 right here. There'd be a common factor of 2. But I can do a negative 1 and I can do a positive 10. So 4x times 10 would be 40x. Negative 1 times x would be negative x. 40x minus x would be 39x. That's not going to get me 3x. I can get rid of that. The next scenario, we could do plus 1 and negative 10. Again, I can't put a negative 10 over here because it would have a common factor of 2 with that 4. So 4x times negative 10 is negative 40x. 1 times x is x. That would be negative 39x. That's eliminated. So then the next one, we have 2 and negative 5. So it's got to be minus 5 and plus 2. Again, I can't put the 2 over here because it would have a common factor with the 4. And this right here doesn't have a common factor in it. It does in the original one, but we already pulled it out. So this should not have any common factor when we consider what's inside the parentheses here, and that's what we're factoring. Okay, so again, 4x times 2 would be 8x. Negative 5 times x would be negative 5x. So 8x minus 5x would be 3x. So this is what we're looking for right here. So let's erase everything and put 4x minus 5 times x plus 2. So again, I know that a lot of you will use this method and you'll like it, and that's fine. Again, I dislike it. I just think it's a little too tedious. I know there's tips and tricks to speed it up even more, but I just don't care for it. So the end result here is 3 times the quantity 4x minus 5, and then times x plus 2. And again, if you want to check it, 4x times x is 4x squared. The outer 4x times 2 is plus 8x. The inner negative 5 times x is minus 5x. So this would give me plus 3x. And then negative 5 times 2 is negative 10. So if we took 4x squared plus 3x minus 10, multiplied it by 3, you get 12x squared plus 9x minus 30, which is what you started with.